Aromatics. Aromatics are based on whether or not they have the benzene ring structure in them. So the benzene is the simplest aromatic structure. Benzene is C6H6. C6H6. It's cyclic, 6 carbons, and for years it's been drawn as alternating single and double bonds. So it has a resonance structure, meaning a different way to draw it. For years it's been drawn as alternating single and double bonds. What they've discovered is that all the bond lengths are the same. So they're not alternating single and double bonds, but they're somewhere in between. But these types of bonds are the reason for its stability. So they know that something is going on. What happens is when you have alternating on paper single and double bonds, you get a delocalization. You get delocalization of your electrons. So you've got delocalized electrons. It's a conjugated system when it's alternating single-double. Benzene is a special case of that. You've got delocalized electrons. So it's very hard to form bonds and become saturated. It's extremely stable. It's very stable. And it's planar. It's flat. It's flat. So delocalized electrons means that those electrons can be anywhere, running around in the circle here. They can be anywhere. So now, because of these delocalized electrons, it's agreed that benzene should be drawn as a 6-member ring, but a circle in between. And that circle represents those delocalized electrons that can move through that conjugated system. So that's the structure of benzene. We're going to focus on structures that have only one of these benzene rings in it. So naming. If there's 6 carbons or lower in the side groups, what you do is you prioritize them alphabetically. So alphabetize side groups alphabetically. And the first side group alphabetically is numbered number 1. And then you number from there, giving the lowest possible numbers. So if we have a benzene ring and we have an ethyl group and a methyl group, ethyl comes first alphabetically. So we say that it's on carbon number 1, and therefore the methyl group is on carbon number 2. So this would be 1 ethyl, 2 methyl, benzene. If the side group has 7 or more carbons in one continuous chain, the benzene is a side group, and the 7-carbon chain is the parent chain. When benzene is a side group, it has a new name, and that is phenyl. So phenyl is used to name a side group that is benzene. So 5, 6, 7, 8. If we have a benzene on an 8 carbon chain, we now have 3 phenyl, because it's attached at carbon number 3, 3 phenyl octane. Follow the same rules for naming as we've been doing before. We know that it's benzene, so that's the root. So we're going to draw a benzene structure. And then we've got side groups. We've got a dimethyl, meaning 2 separate methyl groups. One is on carbon number 1, so designate any carbon to be carbon number 1. By default, usually we number the top one number 1. So that's number 1. And then 4, 2, 3, 4. So it doesn't matter which direction you start at. When they're opposite each other, they're at 1 and 4. So there's 1, 4 dimethylbenzene. Properties: it's nonpolar, contains only nonpolar covalent bonds. It's a liquid at room temperature, and it has a very strong odor. Because it's a liquid at room temperature, that tells you it's got fairly strong intermolecular forces. It's nonpolar, containing carbons and hydrogens, so it must have fairly strong London dispersion forces. The reason they're stronger in benzene is only because of the shape. Because it's flat, it's a planar molecule, they can line up easily together. So London dispersion forces.